Imagine a world with dual-tone skies, dazzling rings that put Saturn to shame, and bizarre creatures beyond your wildest imagination. NASA has discovered distant planets that make our own Earth seem lackluster. These incredible findings could have dramatic implications for the hunt for extraterrestrial life. In this video, we'll tour the most visually stunning exoplanets that put our solar system to shame. We'll explore the alien planets that leave Earth behind and what they can teach us about the extreme possibilities for life in our galaxy. From sapphire worlds to planets where it rains glass sideways, you'll see alien vistas that NASA can confirm exist right now, light years away. With images straight from the pages of science fiction, this galactic eye candy will ignite your sense of wonder. You'll never look at the stars the same way again. Recently, the Kepler Space Telescope uncovered a world orbiting the red dwarf star Kepler 186f in the Cygnus constellation. This faraway planet, dubbed Kepler 186f, is nearly the exact same size as Earth and resides in its star's habitable zone, where liquid water could exist. But unlike Earth's restless tectonics, 186f seems geologically inactive, limiting volcanic eruptions that could disrupt evolution. Its star, meanwhile, emits only half the energy of our Sun, meaning less exposure to harmful radiation. For life requiring stability, 186f may be superior to our chaotic world. But Kepler's most startling discovery came in 2017 when it found the exoplanet Kepler 452b. This distant world is the most Earth-like planet ever detected. It's 60% larger in diameter, orbiting a Sun-like star at nearly the same distance as Earth. Its year lasts 385 days. Models suggest 452b exists as a water world, covered in deep oceans swirling under dense clouds. Its surface gravity is twice Earth's, which could allow for taller mountain peaks, deeper canyons, and more diverse topography, given billions of years to evolve landscapes through tectonic forces and erosion. With a several billion-year head start on habitability over Earth, what awe-inspiring forms could life have taken there? Beyond the Kepler findings, astronomers speculate that billions more life-friendly worlds likely exist, based on what we know about planet formation. The HR 8799 system has 4 enormous gas giants, indicating smaller rocky planets should orbit near their star. TRAPPIST-1 has 7 closely packed planets in its habitable zone, and Proxima Centauri, our nearest stellar neighbor, at just a light year away, hosts an Earth-sized planet within the temperature ring where liquid water could exist. In fact, statistical models now suggest most stars have at least one planet, meaning there could be over 1 billion Earth-like worlds in our galaxy alone. But Earth-like is a loose term. When widening the parameters, astronomers calculate that over 10 billion potentially habitable planets likely exist in the Milky Way, some far more suitable for life than Earth. For example, planets orbiting lower-mass red dwarf stars, the most common type representing 75% of stars, could harbor dense atmospheres that better shield against cosmic radiation, compared to Earth's relatively thin air. Models show that these smaller, dimmer stars are more efficient converters of hydrogen into helium than our Sun, allowing them to shine steadily on the main sequence for up to 10 trillion years. That's over 700 times longer than the lifespan of Earth's Sun. For highly advanced civilizations desiring longevity and permanency, with generations lasting eons, these stable worlds orbiting red dwarfs would provide a nearly timeless habitat. What astonishing feats could an intelligent species achieve if given hundreds of billions of years to progress scientifically and culturally in the same world? Not all habitable planets need to be sanctuaries of peace and stability. Worlds orbiting massive stars live fast and die young, often violently. On tightly packed planets around young stars like TRAPPIST-1, geologic activity could be over the top, with churning tectonics and raging volcanism. This would pose a challenge for life, but also create dynamic opportunities for adaptation. More tectonics means access to fresh minerals atop plates over eons. Frequent volcanism spews useful substances like ammonia into the biosphere. And the energy gradients produced by such planets practically beg for life to tap into them. Earth's own extreme habitats suggest biology will find a way to not just survive, but thrive even in hostile settings, given time. What's more, planet-wide catastrophes can sometimes speed up evolution. The meteor impact that triggered the Cretaceous extinction on Earth opened up room for our mammalian ancestors to diversify and fill new niches. So for planets prone to regular resets, complex life may still emerge stronger despite some setbacks along the way. Challenging worlds teach life resilience and drive incredible innovation. So we should not discount more tumultuous planets as potential cradles of life. Their inhabitants may have mastered existence in ways we can barely conceive. Even the most conservative assumptions make it difficult to imagine such a civilization limiting itself to a single planet over cosmic timescales. Living so close to an active star has drawbacks. Red dwarfs can emit most of their radiation in the infrared range, unlike Earth's sun, which peaks in visible light. While photosynthesis as we know it may be limited, researchers speculate infrared radiation could drive alternative chemistries and metabolisms. What ingenious solutions might complex life devise given an infrared sun? Even on Earth, some organisms can utilize lower energy wavelengths. The possibilities on red dwarf worlds are vast. With endless timescales for adaptation, life finds a way. Tidally locked planets present a challenge, with one permanently hot side facing the star while the far side freezes. Thick atmospheres could transfer heat to the night side though, and life would simply cluster around the rim, where temperatures are milder. High-energy flares could periodically bombard planets around red dwarfs, but radioactivity might drive useful mutations. When red dwarfs do run out of hydrogen fuel, they gradually brighten over hundreds of millions of years, giving eons of warning to relocate or shade the planet before conditions deteriorate. For species with a tremendous lifespan and patience, the payoff is time beyond reckoning to understand the universe's mysteries. Even harnessing just a fraction of a red dwarf's power output could support a Kardashev Type II civilization capable of utilizing the entire energy from its sun. What heights of enlightenment might such species attain, given endless millennia of serene habitation and intellectual pursuits on these ancient worlds? Perhaps to us, they would be gods. Beyond red dwarfs, scientists have their sights on even more speculative havens. Rogue planets adrift without any stars also get residual warmth from radioactive decay and geothermal energy. Such isolated worlds constitute over half the estimated 100 billion rogue planets in the galaxy, and could give rise to exotic life, adapted to permanent cold and darkness. Lacking solar energy, such organisms would rely on chemicals from internal planetary processes. Still, given billions of years, hardy extremophiles might populate the depths, evolving into complex heat-based biospheres, thriving in these refuge worlds detached from stars. Another speculative possibility is that advanced civilizations may intentionally seed rogue planets with life engineered to flourish in cold darkness. Spreading synthetic yet self-sustaining organisms could be an experiment in bootstrapping basic biospheres from the bottom up. Once established, such organisms would continue evolving for millions of years out of sight. This unsupervised proliferation could yield surprises and innovations that even the seeders did not predict. Rogue planets may offer limitless laboratories for daring experiments in guided evolution. Of particular interest are exomoons orbiting huge exoplanets at wide distances from low luminosity red dwarfs. Tidal forces from the massive planet could provide internal heating and vaporize frozen surface water into a hearty atmosphere on a naturally habitable moon, gently heated for billions of years. Teams are now developing methods to detect exomoons hiding in exoplanet data. What rich new biology might emerge on these little worlds so far from their dim stellar hosts? More speculative still are tidally heated moons around pulsars, incredibly dense, rapidly spinning cores of dead stars emitting intense bursts of radiation. Complex organic chemistry might be possible on moons orbiting a safe distance away, where enough light filters through. Hardy organisms could migrate between dangerously irradiated zones and darker protected areas in tidal rhythms, attuned to the pulsar cycles over eons. Though vastly more energetic than our placid Sun, for tenacious life, pulsar systems might provide another path. Even the best conditions imaginable likely cannot compare with intelligently engineered habitats, which civilizations eons more advanced than us could construct. Spacefaring societies may build custom orbital sanctuaries around white dwarfs, fashion rotating habitats with gravity and climate controls, and harness the full energy output of entire stars using megastructures like Dyson spheres. While we depend on finding naturally hospitable worlds, perhaps the most advanced life in the galaxy thrives in artificially engineered environments, not primordial planets. Their technologies may reshape reality in ways undreamt of by nature alone. Not all alien life needs to be biological. Perhaps some technological civilizations have fully replaced biology with synthetic systems optimized for extreme conditions. Beings of pure energy or plasma may exist as stars, freed entirely from matter. Rogue AIs could populate virtual worlds limited only by processing power. Uploading minds to live as software amid simulated universes could be routine. Our imagination of alien life remains confined by assumptions of flesh when, in reality, virtual entities could outnumber and exceed material beings. Still, Earth remains the only confirmed inhabited planet for now. But mathematically speaking, NASA's epic discoveries imply we are far from alone in this grand galaxy. Worlds more diverse than any science fiction could invent patiently await our lenses. What astonishing organisms, never before imagined, might have pioneered exotic biology on these distant orbs. As we slowly expand our gaze across the galaxies, we inch closer to the greatest revelation in human history: that this infinite cosmos holds more creative potential than our philosophy has yet grasped. The limits of life itself are still to be discovered.